Good morning, students. Today's topic in physics is very important one, that is refraction. So concentrate yourself. We are going to start now. The bending of the light when it passes from one material to another is called refraction. It is caused by a change in the speed of the light. Laws of the refraction. The first law is the incident ray, the normal, and the refracted ray all lie in the same plane. And second law is called Snell's law. For two particular media, the ratio of the sine of the angle of the incidence to the sine of the angle of the refraction is a constant, that is sine I over sine R is equal to constant. So these are two laws of the refraction. A light ray enters an other medium perpendicularly to the boundary or along the normal. No deviation of the ray even when there is a change of the medium. So this is very important point. If a light ray enters into an other medium perpendicularly or along the normal, no deviation of the ray even when there is a change of the medium, the light will pass straight along the same line. And here is the example. Here is medium 1, here is medium 2, and the incident ray is at 90 degree to the perpendicular. It is hitting perpendicularly to the surface, so it will pass through the mediums straight away. There will be no deviation. So light is undeviated. Ray of light traveling from air, lighter medium, into the glass, denser medium are bent or refracted towards the normal. So this is very important point. When the light is passing from lighter to denser medium, it will be refracted towards the normal. And opposite is rays of light traveling from the glass, that is denser medium, into air, lighter medium, are refracted away from the normal. So in short words, easy words, if the light is passing from lighter to denser medium, it will be refracted towards the normal. And if the light is passing from denser to lighter medium, it will be refracted away from the normal. And here is the diagram. When light is passing from lighter to denser medium, it will be refracted towards the normal. This was the way of the light ray, but after passing from lighter to denser medium, it will be refracted towards the normal. And from here, light is passing from denser to lighter medium. Here is the normal. So when passing from denser to lighter, it will be refracted away from the normal. Although this was the way, but light will be refracted away from the normal. Angle I is called the angle of the incidence, and angle R is called the angle of the refraction. So the angle between the incident ray and the normal is called angle of incidence, and the angle between the refracted ray and the normal is called angle of refraction. Air optically less dense, glass optically more dense. This is incident ray, this is refracted ray, and this is the normal. Refraction results from the change in speeds of the wave as it crosses the boundary. The greater the change in the speed, the greater is the refraction of the light. The ratio speed in air over speed in medium is known as the refractive index N. from air to medium. So the speed in air over speed in medium is equal to refractive index from air to medium. The refractive index of the glass can be found from another formula called the Snell's law. And Snell's law is sin I over sin R is equal to refractive index. If an object underwater or under a glass block is viewed vertically from above, then the apparent depth is less than the real depth. And refractive index is equal to real depth over apparent depth. These are very important points. Look again. If an object underwater or under a glass block is viewed vertically from the above, then the apparent depth is less than the real depth. So I'm showing you a diagram now. For example, here is an object which is under the glass. When you see vertically above the glass, it will see apparently above than the real depth. More detailed diagram is here. For example, you are seeing an object underwater or under the glass block vertically above the glass. So this will be the apparent depth of the object which you will see, although the real depth was this one. So this was the real depth, but apparent depth was this one, because you are looking the object right above the vertically above the glass. Image trick. Put a coin in the bottom of an empty cup and position your head so that the coin is just out of the sight. How can you bring it into view without moving your head or the cup or the coin and without using a mirror? Simply pour in water. Rays of light from the coin are refracted away from the normal and into your eye so that you can see it. Its apparent position is higher than its real position. So this is the diagram of the trick. Here is the coin and you just move your head so that you cannot see the coin now. Now pour water into the cup. The apparent depth of the coin will be above than the real one. So now you can see the coin without moving your head or glass or a mirror. Next topic in the lecture is the total internal reflection. When light enters from optically denser medium to an optically less dense medium and the angle of incidence is greater than the critical angle, there is no refracted ray. All the light is reflected back into the optically denser medium. This is known as total internal reflection. So the condition is when light enters from denser to lighter medium and the angle of incidence should be greater than the critical angle, there is no refraction at all. Light will be reflected back into the optically denser medium. This is known as the total internal reflection. The diagram below shows what happens to three rays leaving an underwater lamp at different angles. Angle C is called the critical angle. For angle of incidence greater than this, there will be no refracted ray. All the light is reflected. The effect is called total internal reflection. So here are three lights. One is this one, that is below the water. Here is the critical angle. You can see the angle of the incidence in this case is less than the critical angle. So the light ray will be refracted. In this case, here is the critical angle. The angle of incidence is just same as that of the critical angle. So light will be reflected back. So light will be reflected here, and some light will be reflected here. But if the angle of incidence is greater than the critical angle, no refraction will be there at all. All the light will be reflected back into the denser medium. This is called total internal reflection. In this case, angle of incidence is I. This is critical angle, and this is angle of incidence greater than the critical angle. Total internal reflection takes place only when the rays are traveling in a dense medium towards a less dense medium. This is the first condition. And second is the angle of the incidence is greater than the critical angle. So these are the two conditions due to which total internal reflection takes place. Refractive index is equal to 1 over sine C. Next, we are going to read the applications of the total internal reflection. This is an instrument used for looking over obstacles. Prisms reflect the light, although they can be replaced with mirrors. So, this is the instrument. Next is rear reflectors on cars and cycles. The direction of the incoming light is reversed by two total internal reflections. You can see from here. The direction of the light is reversed. Next is binoculars. The lens system in each barrel produces an upside down image. Reflecting mirrors prisms are used to turn it the right way up. Next application is optical fibers. Optical fibers are very thin, flexible rods made of the special glass or transparent plastics. Light put in at one end in total internally reflected until it comes out of the other end. It comes out almost as bright as it goes in, even if the fiber is several kilometers long. Optical fibers can carry telephone calls. The signals are coded and sent along the fiber as pulses of the laser light. Next is this photograph was taken through the endoscope, an instrument used by the surgeons for looking inside the body. An endoscope contains a long thin bundle of the optical fibers. So this picture is taken by the process of total internal reflection. When diamond is cut, the faces are angled so that they produce total internal reflection. Reflected light gives the diamond its sparkle. So this is the technique of cutting the diamond, due to which diamonds sparkle. Mirages are often seen on a hot day as a pool of water on a straight road some distance ahead. Layers of the air closer to the surface of the hot road are less dense than the layers of the air that are higher above the road. Light from the sky is gradually refracted away from the normal as it approaches the hot road. Total internal reflection occurs when the angle of the incidence at a layer is greater than the critical angle. The reflected light that enters an observer's eye appears to come from a puddle on the road. So this is the reason you see mirages on the road, particularly on a very hot day. So students, this was the lecture. Read this lecture again very carefully and make your notes. Thank you so much.